my class diagram again for the linked list. And the top of it is going to call the name of my list. I'm going to call it my linked list. And I need another object. So who knows what is this other objects that I need? We're trying to create a chain of something. What is that thing? Node, exactly. So that is going to be the object node. So we already see that what is inside our node, right? So if you remember, our node is going to have, I'm going to draw this. Our node is going to have what? In the minimum scenario, node is going to have what? We're storing element and what? And a reference to the next node. So for at the beginning, we're going to just make our nodes our string type. Everything is string, and then we're going to switch everything to generic type, so we see what is the difference. So we have our element that we're trying to store, and we have our node, next node. So what is going to be the type of a next node that we're trying to store the reference of it? What is the type of it? So also draw that. So this is my first node, right? And this one is going to have a reference to my next node. What is going to be the type of my next node? What is the type of it? Look at the picture. They're both what? Node, right? So that means I'm going to have a which I'm going to call them my node. But anyway, we're going to have a pointer to our next node. The reference address of the next one that we have in the list. So when I create a node at the beginning, right, and we're adding element to it, and that's the only node in the list, then what is going to be the value of next? No, right? Again, back to the default values that we have in our data fields, right? The default value for any objects or reference type is null, and if you have numeric types are going to be 0, Boolean is going to be false, and so on, right? So since my node is an object, it's a reference type, and we create only one node, and we don't have any other nodes in the list, so that means the next is going to be null. So why we need the my linked list now? Node is not enough. What is the point of having an object my linked list? Yeah, remember we said that each node can tell me who is next, but none of them can tell me who's first, right? And so we need another data structure here to own this chain and maintaining this chain of nodes for us, right? So that's the linked list. So linked list is basically this my linked list object is basically the owner of all of this chain of nodes that we're going to create. So most important things that we sure as we discussed is going to be stored here is going to be a reference to the very first node, and I'm going to call it first, right? So that means when I'm creating my basically list, my linked list, and when I immediately add the very first node into it, I'm going to save the address of that first node inside the linked list. So the relation between these two is what types of relation? Remember, we're talking about different types of relations between our objects, right? So we had inheritance, right? We practice a lot about inheritance, subclasses, superclasses, all the common things go to the superclass. And what was the rule for inheritance relations? Remember, what is the rules? How we know that we identify that correctly between our objects? Like I have animal and I have different kind of animals, right? If I create an animal superclass, what is going to be the relation between cat and animal? Cat is a, right? So the rule for it is a. So that's inheritance, right? So say here also I have an inheritance relation between node and linked list. Do we have that? Is node is a linked list? Is that correct? No. So what is a node? What is the relation between node and linked list? Are they having any relation? Yes.
Node holds the object we're using, it has a reference to the next node, and if it's a double linked list, it has a reference to the previous node. Like the address.
Yeah, so that we have different kind of linked lists, right? So we're talking about a singular linked list, which we basically each node only going to give reference to the next. So just one singular linked list. We're not going to have the point to the next one. We're going to talk about that to the previous one. For now, we're just pointing to the next. But now, that's not my question. I'm trying to see what is the difference, what is the relations between the MyLinkedList and the node. Right, we talk about inheritance, we talk about the composition relation, right? And we also talk about the simple associations. What is this? Yes.
It's aggregation.
So how we know that?
Because linked list has a node or multiple nodes.
Exactly. So what is? Do you want to add something to it? I see your hands was up too. Composition. So we know the composition aggregation is very similar, right? We didn't discuss it. The rules for them is similar, right? So that's basically both of them has a or part of or include relations. So whenever we have objects that own another objects, basically there's ownership between them, then we're basically have this aggregation relation between them. So who is the owner here? Who is the owner of nodes or maintaining this list of nodes? The linked list object. So the owner is basically the linked list. So I'm trying to draw a triangle. So hopefully I can do that, or actually a diamond, right? So it's a diamond. So the owner will have the diamond, and basically the whoever is include or the part of the linked list is going to be the just having the simple line basically. So we have here, we basically what we have a one-to-many relation between them, right? One linked list is going to maintain the entire nodes, right? So we're going to have all of these nodes. So right now you have only one, right? We're only going to keep track of the first one. And another important thing is it aggregation or composition, right? So let's also talk about that. If you're going to create a linked list, do you think your user should first create a node and then assigning the very first one to your linked list? You're basically maintaining two objects, or you rather your users only going to handle one thing, worry about one thing at a time, and basically one objects? Which one is better design? Single objects, right? So because you don't want users to maintaining two separate objects and then handling everything. That's going to create chaos, right? So in this sense, also, we're going to make the nodes private. So node is a private class. Nobody else can have access to it. And only way for us to basically even see what are elements or adding elements or removing elements is through the linked list object. You cannot just go directly to your node object, basically, right? So that's exactly how also implemented in Java library. So in this scenario, since you'll not be able to have access to the node without even go through the linked list, that means this relation between them is a composition relation, right? So we can call it a composition relation. And when it's composition, and composition is a strong aggregation, right? So when it's composition, we're going to call it the black diamond, basically, right? So that means it's like an example that I use for fingers and yes, some of you can see me, fingers and hands, right? You cannot have access immediately when you create your hands. Then you have an empty array list of your fingers, and then you're going to start basically adding them, right? Or automatically all of the five, one of them is going to be created inside the constructor. So that means there's a composition relation. So you're not going to have a finger without a hand. Same here, you cannot have a node without a linked list, right? So they're basically completely included in the linked list. So we know that's a composition relation. Let's write it there as well. And the rule for the composition relation is what? As your friend mentioned, is a has a. It's a very common one, or you can say include of or part of or contain. So the linked list is going to contain all of our nodes. So now we know who's the first now. And so now we're going to start writing some codes. In many of implementation of linked lists, as I said, we have different way or different kind of linked list. The simple singular linked list is only going to point to the first one, and each node is only going to point to the next one. We can make it more sophisticated and make it like a little easier for the user by having another pointer to the very last one as well, right? So we're not only telling our users who is the very first in the linked list, we also can tell who is the very last node in the linked list. So we're going to add that too in our implementation. This is going to make it a little bit harder as far as maintaining, because now you have to maintain two separate addresses every time you're adding or removing element from your linked list. But that's also good practice as far as the coding. So we're going to have maintaining the last. So I'm going to call the last and the first. See if I can move them a little bit. No, I don't know how this works. I have to practice more. Oh, okay, perfect. So this is exactly what we're going to do then. We're going to create our MyLinkedList object. We're going to create a node object, and we're going to start doing, all the things we have to do in order for them to work. And we're going through all the different scenarios that we can have for every single method that we're going to implement. But of course, whenever we have any collection of data, we definitely need to start adding element to it, right? So that's going to be the very first thing. So we're going to have an add method. And we also would like to remove things. We're going to have our remove methods. So we're going to keep adding and removing elements from our list. So that's what we're going to at least implement this too.